in my ChatGPT window um, for end-to-end preparation. So now I'll create my new chat window for the Spark preparation. So let's go in study and learn mode. So what I want to do is learn Spark coding end to end. So the description of this chat is like, you can mention exclusively, increase my volume. So yeah, we need to mention in such a way how we want to prepare for this. Uh, so it's like, test me and improve my knowledge. So that's what I want to give the description to the chat GPT. I'm just giving random things here so that you can the chat GPT can understand and to try to teach me step by step. So I will mention that as well. I want to learn step by step. So yeah. So I'll ping this and I'll see this. So this is a new chat. Okay, I'll edit this name of the chat since we're gonna use keep on in the next sessions as well. So I'll rename it. So I'll put my name. Like anything you can save, like rename Raj Spark Prep. Okay, so I'll save this as is. Okay, now let's start reading what it. Let's learn. Start learning what it specifies. Okay, perfect. So we'll do like a Spark boot camp step by step. Of course, we want the same only. I already know you're a strong data engineering and want Spark end to end. I'll teach it in an interview and hands-on style. Okay, that is the mindset we have. Of course, SQL, we are in the middle of course, you are already aware of that. I opened in the same YouTube channel. I started doing lives as well for the SQL preparation. So we'll continue that as well. But you know, so the same thing here it is mentioning because I'm using the same session, right? The ChatGPT will understand end to end, like where and which areas we are gonna prepare. So we are preparing already. So now it gave a little bit description about how it will teach us end to end. So basics and mental model. I'm not sure about the mental model what it is. Data frame basics and reading data, select, filter with column, cast, null handling, group by joins, window functions, Spark SQL, performance tuning basics, partitioning, shuffle, cache, and real ETL patterns, and all the other stuff. Of course, it will give a few more details as well. And we will do each topic in this pattern quick concept, one small code example, one question for you. I correct and level you up. Okay, so if there is any issue in the question, whatever it specifies, and if I answer correctly, then that's good. If it's not answered, it needs to be, it'll teach me in a better way. So core area Spark is a distributed data processing engine. Of course, we already know. Mm, the mental model it is specifying is driver, brain that plans work, executor is also um, workers the data workers that do the work, actually partitions chunks of data processed in parallel, transformations lazy step like select filter, action is like a trigger point to trigger the entire execution. So the useful shortcuts are useful shortcut. Spark does not do work immediately for the transformation. Of course, it's a lazy evaluation. We already have a basic idea about it. That's just so in so before attending this session, right, you need to have a basic idea about Spark. This session will teach you, step by step coding level perspective, end to end, like coding level improvements. Um, so that's what we're going to learn here. So let's see some example here, like a useful shortcut. Spark does not do the work immediately for transformations. It builds a plan first and then runs it when an action happens. So it's a physical plan, I believe. It gave some code like df equals to spark.read csv, and the csv file and header is true. Uh, and filter is an action, and of course show is an action, filter is a transformation. So that action triggers the entire thing, will trigger all those transformations. So for example, actual execution started show. Now your turn, one question only. In Spark, what is the difference between transformation and an action? So we can say when, okay, I'll use the audio. So it's like when action triggers, then only the transformation will happen. Transformation is the modification of the data, but it won't happen until the action is performed. So that's what I'm gonna mention, and we'll see how it works. Just one important refinement needed. You said transformation is modification of data. No, small correction is transformation does not actually modify data immediately. Of course, it won't do immediately. My intention was to to specify that the instruction actually. Okay, so it says in my intention was to it can change the data, but not until the action is performed. That's what I was supposed to say. But yeah, um, think like this transformation is like an instruction or a plan, and uh, action equals to execution trigger. Mhm. Spark builds a DAG, of course, the execution plan first, and then runs it uh, only when needed. Okay. To quick check, answer this. Okay. df.read.csv file csv. Select. No, it won't. Just a select. So it's not an action. So that's why it is not. It won't read anything until the action is performed. So the mm, okay. So now let's deepen that. Uh, this is where interview level clarity comes in. Why? No, because all these are transformations. Okay, of course, that is I already specified. Spark just building a logical plan like read, filter, select. Of course, there is another arrow need to be there is another arrow should be there, and it should have an action so that it will trigger entire plan end to end. Okay, so now the important jump. Don't skip this. Okay, if I add show, then yeah, of course it will. If I add the show, it will trigger an action. It will perform all the operations. Okay. Uh, what is exactly now happen now in this case is uh, I want you to think step by step. The Spark execute only show or the full pipeline? What order? Answer in one or two lines. Okay, so I want to explain this in one or two lines. Okay, so okay, this will start executing the entire code statement by statement. First, it will read the file, and after that, it filters based on that and select the name as well, and then it will give you the result. So it will be like an internal plan will be there. Like that plan will be executed after the action is triggered. I'll submit my answer. Yeah, that's the right idea. Okay, let me tighten the wording a bit so it becomes interview strong. So the main aim for the session is to, we will be strong enough to crack the interview. So that is the reason we are created our window is like that. I mean, we our chat like that with ChatGPT, to prepare ourselves in an interview purpose. Okay, better version is, when df3 dot show is called, Spark execute the whole lineage or pipeline, not just show. Okay, so the order is, read the file, apply filter, apply select, and return display the results for show. So show is the action, but Spark runs the transformation that lead to it. Okay. So one important correction in this. Okay, you said thread. Here the better word is plan or dag, not thread. Okay. So we need to use dag. So the moral of the story right now, what we where we are it is. So when the action triggers, the Spark prepares a DAG. The DAG will be executed step by step to give the result. So we can say in that way. Okay, next. So for the memory trick, transformation is like a recipe and action is a cook now. Okay, next. Now let's move to the next core concept. Why does Spark split data into partitions? Uh, okay, so Spark is a distributed computing engine. So if you if you partition the data, right, the processing will be parallel. So to to perform the parallel execution, so Spark will split these things into partitions. So I'll submit this answer and we'll see. Oh, sorry, I mistakenly did it again. Okay, so Spark will split data into partitions to perform the actions in pipeline, in parallel, as it is a distributed computing platform. Let me submit this answer. Yeah, sorry. Okay, so let's go to the better version now. Let's stop it. Let's stop it. Let's create a better version now. Okay, it is there. Spark is distributed computing engine. Okay, I'll remove this. Even though, of course, it's a accidental. I gave a good example here. Whenever we accidentally texted something wrong, so we can just delete and we can submit that answer so that it can read easily. Okay. That solid answer, exactly right direction. Okay, let's sharpen it to interview grade level, clarity. Okay, your idea, redefine. Okay, refined idea. Spark splits data into partitions so that each partition can be processed in parallel by different executors and cores. Okay, so more partitions, more parallelism. Maybe you might have an idea about the parallelism. Means parallel processing can be called as parallelism. Like, data will be partitioned into different chunks of data so that, whatever the action you triggered from the Spark, that will be applied on each partition and it will execute individually and it will combine the result later. Okay, that is the best way, best thing in the, Spark environment, so that it will create a best framework to, execute in a parallel processing way. Okay, let's go to the example. Small upgrade to your thinking. Okay, it's not just to split data; it's also fault tolerance means and scalability. Mhm. Okay, fault tolerance. Let's go a little deeper into these concepts. Fault tolerance and scalability. Scalability, I already, I am aware of that particular scalability. Like, so whenever you built something, that should be scalable for, means that should that can be performed with any number of huge data, right? Even though data increase also, accordingly the scalability should be increased, and so that it will be able to, the model whatever you built, the process whatever you built, it should be able to accommodate everything. So the processing of huge data as well and the small data as well, so that is scalability. And fault tolerance is recompute only failed partitions. Okay, for example, uh, if you are executing something and it failed in between, and whenever you retrigger the same thing again, it should start from there itself. It should not it should not start from the beginning. So if it's done like that, whatever the calculations already performed and stored into the system, it will be corrupted. So for that, it's best feature for from the Spark environment itself. Okay, quick visual of a mental model, whatever we specified in the past. So data P1 is equals to, means partition 1 will go to task 1, partition 2 will go to task 2, partition 3, and so on. Each runs in parallel. So that is the parallelism we are going to achieve. Okay. Now let's test your understanding. If I have 4 partitions and 2 cores, how many tasks run at the same time? 2. Let's submit 2 tasks. Okay, because 2 cores are available, and since partitions are 4, so first 2 completed, and after that, the second 2 will be picked up. So you're getting a core execution model. Okay, right. So let's lock this concept in. Okay, so you had 4 partitions, 4 tasks total, 2 cores. Only 2 can run in parallel. So wave one, task one, task two will be completed. And after that, it will pick up wave two, task two, and task three and task four. This is called task scheduling in batches. Okay, so okay, so in the Spark engine internally, it will split the it will just segregate the process, and as per the plan only, as per the built-in DAG directly acyclic graph, it will pick up one after the other and it will process in those in a batches manner, and each batch will be processed at a time. So that is the way Spark works. Okay, next small upgrade, very important concept is parallelism. Yeah, that's fine. Next, quick check. Okay, if I increase partitions from 4 to 100, but still have 2 cores, will my job become 50x faster? This is a good question. Just thinking about it. Mm, I don't think so. It will be 50x faster, but as 2 cores are only available, so at every point of time, only one wave have 2 tasks, 2 partitions only. It will consider. So uh, it will be slow only, I believe. Let me submit this answer. Okay, I'm very close, but not I'm exact. Okay, let's. Okay, it says good thinking. You are very close. Let's refine in a bit. It a bit. Okay, so it will be slow only, not exactly slow only. This is a key nuance. Okay, what happens? Okay, correct understanding is with 100 partitions, 2 cores. Yes, only 2 stars run at a time, but total work is split into smaller chunks. So wave one, 2 tasks, wave two, 2 tasks. Okay, this it seems to be slow only, but I don't know why the GPT is saying like that. Maybe the we need to go a little bit we need to go little deeper to understand this concept. So let's go a little deeper as well, and we'll see. Okay, so what actually happens? Not 50x faster, not necessarily slower, more overhead, task scheduling, shuffle, etc. Okay, can help in better load balancing. Key takeaway, very important for the interviewers. Too few partitions, underutilization, too many partitions, overhead, optimal partitions will be balanced. Okay, so the partition should happen depends on the data as per your need in a way, so that the Spark engine can perform uh, those tasks in an effective manner. So that's what it is saying is here. So if you have more partitions also, it's not like 50x faster. If you are less partitions also, it's not like it's not like it is utilizing properly. Your resources will be wasted, of course. So the optimal partitions based on the need is the right way to understand your task in a better way. So based on your needs, you need to increase. You may need to increase cores, and sometimes you may need to increase partitions as well. Okay. So now I want you to think deeper. This is where most people fail. Okay, which is worse and why? Okay, the example one says two partitions and eight cores, and the example two says 100 partitions and two cores. Pick one and explain in one or two lines. Okay, which is the worst? I think two will be the worst because two partitions in eight cores, even though eight cores are there, two partitions will be run quickly and it will just keep quiet. And after that, I mean, it's not like that the entire eight cores are keep on running for the two partitions work. It just utilize whatever the course it is needed, and after that, it will just keep quiet, finish the job. But I think the second one will be worst. 100 partitions and two cores will be worst, I believe. Okay, I'll answer that as that only. Well, let's see what happens. Okay. So in this case, the option two, which is 100 partitions, two cores, will be the worst because the task one is two partitions, eight cores will complete quickly, and after that it will keep quiet. Okay, let me submit this and I'll see what it will say. Good attempt, but this is where we refine your thinking. Okay, your answer picked option two, but that's not correct. Okay, why? Let's break it carefully. Case 1, two partitions, 8 cores. Only two tasks in total. Max parallelism is 2. 6 cores are idle. Okay. Next, 100 partitions, 2 cores. 2 tasks run at a time, but all cores are fully utilized continuously. Just more wave overhead. Which is worse? Case 1 is worse because you're wasting resources. Okay, you cannot scale performance. Under partitioning is worse than over partitioning. That is the worst. Okay. So okay, as per this, if you don't utilize the resources correctly, if some cores are idle, that will be considered as a worst performance. So okay, that's a good thing to understand, good thing to learn as well. Okay, so the case one is worse. Okay, next. Key interview insight is like under partitioning is worse than over partitioning. Okay, because you lose parallelism completely, you cannot recover performance. Over partitioning adds overhead but still uses full capacity. Okay, if you define a system in the Spark environment, so that system should utilize its full capacity. Then it's a right system. So that is what I conclude from this. So yeah, let's see how it goes from the next thinking perspective as well. Okay, uh, Complete this sentence. Best number of partitions should be slightly slightly more than. Yeah, more is correct. Because whatever we have learned till now, that is the basic concept. It explained that your environment should be utilized fully and in a proper manner, so that then it's a right system. So in that way, it says it's worse, and if you underutilize your environment. Okay. Next, best practice. Number of partitions should be slightly more than cores to keep all cores busy and handle skew. Okay. Quick reinforcement. Log this in. Okay. Equal to cores. Okay. Slightly more optimal. Too many overhead. Very too few is the worst. Underutilization is the worst. I mean, in short, the course whatever you are using, it should not be underutilized all the time. So that is the main motive we need to keep while writing a programming and while building a data pipeline in Spark. Okay, now let's move to coding. uh, okay, I'll take this in the next session, as we in our current live we are just doing an intro as of now. So it has basic information as of now. But before that, let's ask the system. I'll say that, okay, let me say that. Hey, before going to further technical area of this Spark, I just want to know what exactly the key notes in the functional area, so that, we'll have a better idea going forward. So give me the all key concepts before coding itself. So let's read out these things, um, so that, we can understand the end-to-end basics of Spark. Spark functional core. What you must know before coding. Okay, so one is, okay, execution model. You already started this. Driver creates plan. It's a DAG, directed acyclic graph. Like, I mean, it's a graph. The way your program will be executed after an action is triggered. So that is the DAG, end-to-end plan, how to execute a particular task, the particular work in the Spark environment. Executors run the task, of course, and transformations are little lazy, and actions are trigger execution. That's the only thing. You already understand this as well. Nick, data abstraction, very important. RDD is an old system, of course. It's a core system of Spark. It's low level, more control, not commonly used now, of course, and data frame most used. Table-like structure optimized by Spark Catalyst, of course. Spark has a catalyst. That's an engine, or that's a core of the Spark, which will compile the code and make it ready for execution. Mm. Because it will convert, the catalyst is the only one, it will convert the code to JVM and give it to the JVM so that it will be executed. What you will use in interviews? Data frames are the most. Data sets. Scala only, because the type safe version of data frames for you, focus equals to data frame. Okay. Next, lazy evaluation. We already know Spark builds a logical plan, optimizes it, executes only when needed. Benefits: avoid unnecessary competition, combine operations efficiently, because the planning is such a way, it has a better planning. So that planning is there. So that's why execution only when it occurs. Yeah. And it will combine operations efficiently. Next, DAG. So read, filter, join, aggregate. It will plan everything like end to end, from where it needs to start, where it needs to be executed, and everything. It will plan. Didactic acyclic graph is the one. Mm. Spark converts this into a stages and tasks. So whenever shuffle kind of operation is there, it will create another stage. That's what I know as of now. But yeah, we'll go deeper into that while we're learning coding. Transformation types. Narrow transformations, like it should not have any shuffle. That's a narrow transformation, like select filter with column. Wide transformations, of course, those have a shuffle that requires a shuffle, um, like group by, join, order by. Shuffle, a critical concept. Data moves across nodes, happens in joins and aggregations. So costly because network, disk IO, and serialization will be there. Yeah, shuffle is the costly operation. Since it's, for example, if you take in this case join or aggregate, the incoming data will be read, and of course it will distribute uh, accordingly to the conditions whatever you have specified in the join, and it needs to match, and it needs to create a chunks of data in a separate groups of data. So then it will aggregate accordingly. So that's why the shuffle will happen after that. So that's why it's since it's a critical operation, it involve network and disk IO and serialization. So that's why it's a little costly thing. Next is partitioning. Of course, it's a it's a chunks of data processed in a parallelly. So we need to be it needs to be partitioned. Each partition is one task. So controls like parallelism and performance. Of course, catalyst optimizer. It's a catalyst optimizer is the main engine which will convert everything into a proper code. So what it will do, Spark automatically reorders the operations, pushes filters down, optimizes joins, and everything can be done in Catalyst only. Actions and transformations, of course. Actions transformations are to build the plan, and of course actions is to execute everything. Persistent is the cache. If a data frame or any chunk of a data you want to use again, you will cache them into the memory, so that it will be available for this session, irrespective of the sessions. Maybe that is the reason. So yeah, that's persistence. And fault tolerance, of course. When anything fails, if you retrigger it again, it will start from the recomputes from failed partitions only. So that is the reason it will be really helpful to understand. Now let's check your understanding. Okay. Question: which of these causes shuffle, and why? Group by is the one who creates the shuffle. So just test basis, I'm just answering this, and let's after this let's end this session, and we'll open another session for the next live. 1 minute. Hmm. Why does group by causes shuffle? Think step by step. Data is spread across partitions. Same DEPT values may exist in different partitions, so it needs to shuffle. To count correctly, Spark must bring same keys together. That's why shuffle will happen. Data movement across partitions is called shuffle. Data movement across partitions is equals to shuffle. So that's why shuffle will happen. Okay, let's end this session with the core concepts and intro towards our learning journey with the Spark. So let's end this session here, and we'll continue with the same in the next session. So thanks. I'm ending the stream. Thanks a lot, and please subscribe to my channel.